Okay, so this is the third and final type that we're going to solve. These are quadratic type. We say quadratic type because that's how we work it. We work it just like a quadratic equation. We factor it, set each factor equal to 0, and then solve for each x. The clue, though, whatever your highest exponent is, that's how many solutions you're going to get. This one, you get 4 solutions. This one, you get 4 solutions. So let's factor it just as if it were an x squared. And you know I do slide and divide, so 12 times 2 would give us x to the 4th minus 11x squared plus 24. So let's factor that, x, oops, this is to the 4th. But we know that x squared times x squared gives us x to the 4th, because remember your intermediate algebra, x squared times x squared, if it has like bases, you add the exponents. Factors of positive 24 that add up to a negative 11, I think minus 8 minus 3. Then divide by your a term again. If we simplify, that's going to give us 4 goes into 8 twice, and 4 goes into 12 3 times. So 3x squared minus 2. And here, 3 goes into 3 once, it goes into there 4. 4x squared minus 1. Equal 0. I kind of made a mess there. Okay, so this is our factor form, but we still have to set each factor to 0. So you've got 3x squared minus 2 equals 0. 4x squared minus 1 equals 0. Well, this one is the difference of 2 squares. It's still quadratic. We've turned it from a quadratic type to quadratic. And we know from 1.4 we have to solve it by the zero factor property, or we can. So difference of 2 perfect squares, remember, square root minus square root plus square root equals 0. So now we can find x to the first power by setting all of these equal to 0. So x equal negative 1/2. X equal positive 1/2. And if x squared equal 2/3, then x would be plus or minus square root of 2/3, right? And there's your 2 solutions there. Now this little booger right here, you can't leave a radical on the bottom, right? So we have to simplify it when a radical is on the bottom. So what we need to do, we need to do it in lowest terms. So if we have square root of 2/3, we have to rationalize. Take the bottom number, square root 3 over 3, because it's really 1. But what happens, you've got square root of 6 over square root of 3 times square root of 3 is square root of 9, which is 3. Now that's not so important for right now, but I want you to know why you learned that back in Algebra 1, because you did. So we have our 4 solutions. Let's see. Okay, so we have another one. 4x to the 4th minus 8x squared plus 3. Let's do the same thing. Let's factor it just as if it were a regular quadratic. 4 times 3 is 12. So we have x to the 4th, 8x squared plus 12. X squared times x squared is x to the 4th. Factors of 12 that add up to a negative 8. I think both would be negative. So let's divide the 4 back out. That reduces to 1/2. 2x squared minus 1. And 3 goes into 6. No, 2 goes into 6 3 times. 2 goes into 4 twice. 2x squared minus 3. Set equal to 0. So we solve for each x. Add 1. Divide both sides by 2. So x would be plus or minus square root of 1/2. If we come down here and we simplify that radical, take the denominator, and it's the square root over 2 over 2. So that would be square root of 2 over 2. Is how that would actually pan out or simplify. Here, add 3 to both sides. X squared equal 3/2. Take the square root of both sides to simplify that radical. And when you have to simplify a radical, it's because a radical is in the denominator. If you remember. You may not remember unless you just had it last year. 3 times 2 would be square root of 6. Square root of 2 times square root of 2 is square root of 4, which is 2. So this would actually be the final form. And you've got 2 solutions here and 2 solutions right there. All of those work the same way. So practice all of these for class. Attempt your homework. And we'll talk about it, though. I'm not going to check homework, but I do want you to do some. And we'll work some in class to try to get this down pat. But I want to see that you've taken these notes and that you've made an effort. See you next class.